Hi, thank you very much for joining our session today on Couchbase Cloud Native Databases on Kubernetes. My name is Mook Srinivasan, and along with my colleagues Daniel James and Kevin Farley, we're going to walk you through why Kubernetes, show it to you, and then finally wrap up what the details are. Thank you for your time. So overall, the Couchbase key pain points are companies have created data silos. They have created situations where they have cloud vendor lock-in, and then ultimately this leads to higher operational costs, kind of creating the problems you had in your own data centers now in the cloud. By adopting a cloud native database, you're able to bring forth the continuous delivery that you're already doing with your code development. You're able to leverage containers and everything a container deployment allows. You're able to leverage microservices even down to your databases, and ultimately your DevOps team now focuses on the availability as opposed to managing a database. So by defining how large and how small, it will automatically scale in and out. How does it do that? With the Couchbase Autonomous Operator, we maintain all of the best practices of observe, analyze, and act in a continuous loop, which is built atop Kubernetes and leverages the code of Couchbase. So ultimately, your developers are still using the exact same database while your SREs and operations team are managing it just like any other kube container. It fits within the existing Kubernetes ecosystem. So your CI/CD brokers, microservices are all built atop our autonomous operator. The Couchbase clusters operate just as they would if they were in dedicated servers, and they have leveraging storage as well as the networking and alerting systems of monitoring and logging. So instead of me continuing to talk about this, well, let's show it to you in action.
Hello, my name is Daniel James. I am a solutions engineer for Couchbase, covering Western Canada. And today I want to show you a demo of the Couchbase Autonomous Operator. Now, the Autonomous Operator, as you know, is a great feature built into the Couchbase Enterprise Edition that can handle building out your cluster, maintaining the integrity of your cluster, the size of your cluster, so that if any of your nodes were to fail, then the Autonomous Operator would recognize the failure of that node, bring in an additional node, and perform a rebalance if necessary, or use persistent storage so that the rebalance, or ideally, would not be necessary. It allows your cluster to sort of operate in a hands-off capacity so that your operations folks can maybe sleep through events that might occur in the middle of the night. But another great feature of the operator is the fact that it handles auto-scaling capabilities as well. So imagine you are running a retail store and you have an event such as Black Friday, Memorial Day, Labor Day, the holidays, something where you have a peak event that causes traffic to spike in your database. Now, maybe you have a small cluster. Let's say you have 5 nodes, and that's sufficient for everyday operations. But when you have one of those peak events, maybe you need 10, maybe you need 15, something to handle that increased workload. But you don't want to pay for that infrastructure when you don't need it. So you don't want to pay for 15 nodes and the infrastructure running behind those during the 80% of the time when you don't need that much infrastructure. So you'll run with the 5 nodes you need, or however big your cluster is. And then when you have those peak events, the autoscaler built into the Autonomous Operator will automatically give your cluster additional resources to handle that peak workload. And then when that workload slows back down, the automator will, the Autonomous Operator will shrink that cluster size back down to save those infrastructure costs. So what I want to do here is demonstrate a real world scenario. Just like that, it can be based on CPU utilization. It can be based on query response time. But in this case, what I want to show you is an example of key value operations. When they reach a certain threshold, we want to give more resources out there so that that cluster can handle that increased traffic. So what I have here is a YAML file, which is used to define the cluster You can see here we're running Couchbase Server 7.01, which is the current release of Couchbase at the time that this recording is being made. We're defining that cluster to have 4 gigs allocated of quota to the data service nodes, and then 6 gigabytes allocated to the index server. We've got an exporter for Prometheus, which is required for monitoring those, the performance, basically. So in here, we're also defining a pretty small cluster. We're doing 2 nodes running the data service, and then down here, we're running an additional node, which has the index query services running on that, although we really don't need it for the purposes of this demo. And then once that cluster is defined and created from within Kubernetes, that operator is going to go ahead and it's going to create a bucket called travel sample. We're using the Couchbase bucket type, which is sort of the default. It's the, it's got that the built-in cache, but it also has that persistence layer. For the purposes of this demo, we could very easily also use an ephemeral bucket, which does not have the persistence. It would be a memory only. We're defining a value only eviction policy as opposed to full value. But again, we're allocating 1 gig of RAM for each one of the data nodes for this bucket. So that's 2 gigs total. We're not going to come close to that for the purposes of this. And then we're also going to create a user. So a lot of the stuff not necessary for the purposes of the demo, but just to give you an idea of the capabilities, the operator can handle basically almost every operation of managing your Couchbase cluster. So that's the definition of the YAML file. I've gone ahead and already created this cluster using the operator. So you can see in here, this is a dashboard. We've got some activity running out there, which I'll show you in a second. Here's our 2 data nodes. Like I mentioned, 4 gigs of RAM allocated to each one of those. Enterprise Edition 701. That's the data nodes. And then we've got the 1 node here running with the query and index service with 6 gigs of RAM allocated to that index service. Here's our bucket that we created. This is the travel sample bucket. And you can see there's some activity around here, 140,000 operations per second, roughly. Pretty small, even for a 2-node cluster. But what I want to show is what happens when that activity level increases using the operator. And to do that, we need to create a horizontal autoscaler service. So let's take a look at that. So we're creating an autoscaler here using the Kubernetes. We're just calling it data ops HPA, so the data service, operations per second, and horizontal pod autoscaler. This can be anything you like. But what's important down here is the metrics that we're reporting on. So we've got built-in metrics here. In this case, we're looking at the bucket info, operations per second, against that travel sample bucket. And then we're looking for where that average value is above 200,000 reads per second. So as you can see here, we're not quite reaching that yet. But let me go ahead and create the autoscaler using that definition here. So to do that, we do kubeapply f. That's all it takes. So now the autoscaler is actually running against the cluster, keeping track of those metrics, looking for an increase in that threshold, and then we'll perform the scaling automatically. So we want to take a look and see what that looks like when we do describe against that here. So we've got some information here on what this autoscaler is looking for. Right now, we have not actually triggered the scale event because, as it says here, the desired count is within the acceptable range. Well, I'm going to push this outside of its range. And I'm going to do that using something called pillow fight. So the activity that you're seeing running in the cluster right now is already running because I've got this pillow fight running here within Kubernetes. What I've got is I've got 2 instances running. These are multi-threaded, so we're running 3 threads of pillow fight. Pillow fight is a built-in tool that comes with Couchbase. It's in the bin directory. And this can be used by your operations folks to sort of stress test the system and ensure that you've got scale defined well enough to support potential workloads and things like that. So if I look in here and I do a get pods, I can see that right now I've got these 2 running. But what I'm going to do is I'm going to add 3 more. I'm going to do kube control apply. So that's going to add 3 more. So now we're going to have 5 total, 15 threads total hitting this system. And we'll start to see these operations bump up. So once this reaches that threshold of 200,000 operations per second, and it maintains that for a period of time that's defined in that auto-scale YAML file, we're going to start to see this increase here. Again, right now we've got 2 data nodes. And what we're going to see in here pretty soon is we're going to see an additional data node added in here to handle that. And we can take a look here if we do a describe again and take a look at that. So it hasn't triggered that threshold of 20 seconds yet. But we should start to see that happening here pretty soon. There we go. So now you can see we've added a 3rd node. The reason is because we're above the target. So it's going to take a moment for that Kubernetes pod to be created, to deploy a Couchbase container within that pod, and then perform the rebalance. But this happens automatically. Again, this is something that could be happening in the middle of the night. Your operations folks are sleeping right through it. Come in the next morning, find out something happened here. We can see now we've got this rebalance occurring. So pretty quickly in here, we now have a 3rd data node. And in that YAML file, if you remember or if you noticed, when I look in here, I've created a maximum here of 10. So because of the way this is defined, it's going to continue to increase all the way up to 10. But now that we've got 3 of them, what I'm going to do is I'm going to go ahead and I'm going to shut those down. In fact, I'm just going to shut down all of them. So that'll bring the activity level down to 0 on this. And at some point now, we should see that 3rd data node, as the operations per second begins to fall off, we should see that 3rd data node actually disappear from the cluster. Takes a little while for those Kubernetes pods to fully shut down, so they're still kind of running out there in the background. In fact, there's a good chance it's going to trigger a 4th node here while these things are still in the process of shutting down. Do Q control get pause. We've seen here that they're terminating. The last one is still shutting down in here. Looks like we managed to beat that threshold. So there we go. So now we're doing a rebalance. We should see in here. Took a minute. Some of those nodes ended up falling off. We'll see that last one fall off here shortly. Again, that's a very high-level overview of the Autonomous Operator. Hope you enjoyed it. Enjoy the rest of the Couchbase Connect conference. Please reach out to your SE if you have any other questions about this. We're seeing here the last of these things drop off. There we go. There we have it. Thanks very much for your time. Enjoy the rest of your day.
Now that we've seen Daniel's demonstration on how to automate a lot of your core daily operational tasks on Couchbase Cloud Technologies, let's take a look under the covers and see how that actually works. So as we can see, the Couchbase Cloud Native Database running on Kubernetes is leveraging the Couchbase Autonomous Operator, and that is the core product that is going to integrate with the other cloud native technologies, whether that's Core DNS, Istio Service Mesh, FluentBit, and that is going to basically provide the management intelligence of the application as it runs, managing the lower-level Couchbase cluster, the data service pods, your queries, search capabilities, analytics, eventing services, as well as integration with Prometheus and the alerting manager. And that's going to all be managed for persistence using persistent volumes, using Gluster, Ceph, or Portworx, giving the ability to natively interact with the hardware architecture to give you an optimal performance, more consistent performance, and a higher degree of availability and reliability. Now, the Couchbase Autonomous Architecture, you're going to have your Kubernetes cluster, and of course, at the top level in the key namespace, you're going to have your API server, your controller manager, your scheduler, DNS, and etcd, of course, which is the open source distributed key value store that you use to manage and hold the critical information that the systems are going to need to keep running. Most notably, it manages things like configuration data, state data, and so forth. And beneath that, we have the Couchbase Couchbase Admission Controller, and that's going to handle things like mutating configurations and validating the configurations using webhooks. And then beneath that is where the Couchbase Autonomous Operator is going to operate. And that's going to control the pods, the services config maps, your various resources, buckets. Of course, Couchbase, we call database a bucket. And that's going to manage your bucket resources, the resources of the cluster, replication, your secrets, backups. All of that is going to be managed through the Autonomous Operator. And the key thing to remember is the Autonomous Operator is built from Couchbase using a lot of our best practices we've developed over a considerable amount of time and deployments with a lot of our customers, and really building a best practices intelligence inside the Autonomous Operator. So essentially what we're doing is we're teaching Kubernetes to understand how Couchbase works, how Couchbase needs to run to be optimal, and how to manage all of those unique services to give you that integrated single point application that can manage all of your data requirements, search, query, combine query with FTS conditions, indexing, eventing, and then of course the monitoring capabilities in your namespace using Prometheus and Grafana to track all of those key metrics to really get a consistent long-term historic understanding of how your application is working, how the automation is performing, and is it accurately reflecting the transactions? Because, of course, as we've seen, you can set your Autonomous Operator not only to manage based on server metrics like CPU utilization or memory utilization, but also more importantly, things like transaction levels or transaction performance and latencies. Because again, if you're simply limited to just tracking or creating your growth and your contraction metrics based on the server levels alone, you're really not quite serving the application so much as you're serving the underlying hardware. With the Autonomous Operator, that key understanding of how the application needs to perform is going to be built into that operator, and it's going to give it that native capability to manage effectively the application and to make sure that it's always going to be optimal for your application performance. And of course, key thing is again, we are going to be natively interacting with your persistent storage. And that includes, you can actually increase your volumes if volume expansion is supported by the underlying hardware. So again, just to recap, what are the benefits? Again, the ability to avoid those database silos, to be able to deploy and run and manage your Couchbase database and next to those microservices applications on the same Kubernetes platform. And again, having that native capability along with having that database and Couchbase direct knowledge to make it perform at an optimal level. And again, supporting hybrid and multi-cloud strategy, cloud agnostic, again with Kubernetes, supporting most of the most common and most standardized native technologies within the Kubernetes architecture. Give us the ability to deploy on multiple clouds, whether it might be AWS or GCP, Azure, or a combination hybrid with bare metal and public cloud or private cloud, having the ability to manage that deployment through a single control plane and be able to automate those tasks. And allows you to easily manage and deal with that growth. Last, automate our operational best practices, reducing your DevOps workloads by running Couchbase as an autonomous, fully managed, stateful database application. Because a lot of people for a long time have said, oh, hey, we can manage that. In most cases, that's stateless. If you need a fully reliable, fully available, highly available, and persistent application, that is a much, much more difficult task. And what Couchbase's Autonomous Operator does is allow you to run that in an automated fashion and still manage that even in a stateful application. And again, reduction in operation complexity. Once again, we thank you for your time, and we appreciate your interest.